Welcome back. Today we're going to take a look at some trigonometry and talk about even and odd functions among the six basic trigonometric functions. All right, so let's start with our unit circle and let's pick a point in the first quadrant. Okay, right here. Let's call that ordered pair xy. Let's suppose that our terminal side in blue makes angle theta with respect to the positive x-axis. Okay, then let's drop a vertical line here down from that point. It's going to intersect in another point in the fourth quadrant. Let's suppose that point has ordered pair uv, and I think we can probably easily convince ourselves that this terminal side in red is going to make an angle negative theta. Okay, clockwise angles are negative, but otherwise it has the same absolute value as our angle in the first quadrant, theta. So theta and negative theta. Okay, another important thing for us to remember right now is that our x and y values for points on the unit circle are x equals the cosine of our standard angle theta, and y equals the sine of theta. Okay, so this groundwork here is, really gets us quite a bit of ways into the argument. Okay, now because this green line is vertical, okay, what we're finding here is that u should be equal to x up here, and then v it has the same absolute value as y, but it is down in the fourth quadrant where y is negative, so v is equal to negative y. Now, just as we can write down cosine and sine values for x and y, u is really an x-coordinate in the general sense, so that's going to be cosine of that standard angle, cosine of negative theta. V is a y-coordinate in that general sense, so it's going to correspond to the sine of negative theta. Okay, now we're really pretty much there in terms of sine and cosine. So if u equals cosine of negative theta and x equals cosine of theta, then what we're finding here is that cosine of negative theta is just equal to cosine of theta. Okay, in other words, that negative sign on the angle just doesn't matter. This is an example of what we call an even function. Okay, when the negative sign just can be eliminated. All right, now on the other hand, y is equal to sine theta, v is equal to sine of negative theta. So if v is equal to negative y, that means we can take sine of negative theta and set that equal to the negative of sine theta. So here, this is as if the negative sign on the angle in sine negative theta just comes through the function and comes onto the outside. Negative sine theta. Okay, so cosine is an example of an even function. Sine is an example of an odd function. Okay, now what about all the other four trig functions? Okay, well let's make a clean screen here and find out here in a minute. Now let's take a look and see if we can figure out if tangent is an even function or an odd function. So the way to start this is to ask the question, okay, how can I resolve tangent of negative theta into one of the above, either tangent of theta itself or the negative of tangent theta? Okay, well what we need to do is just kind of start with what we know. We know that tangent is sine divided by cosine, but we have to respect what the argument of the function is. Okay, it's negative theta. All right, now we happen to know the required properties here for sine and cosine. Sine is an odd function, so sine of negative theta is negative sine theta. Cosine is an even function, so that negative can be disregarded. So in the denominator, we just get cosine theta. Okay, and now we're pretty much there. Okay, the sine over cosine part, well, that's tangent. Okay, so I have a negative left over from our operations here. And then in parentheses, that is tangent theta. Okay, so if you take a look at the two extreme sides, I have tangent negative theta equaling the negative of tangent theta. So this makes tangent an odd function. Okay. All right, now a similar procedure can be done to try to figure out whether or not secant, cosecant, and cotangent are even or odd functions. Okay, well, I'm just going to write them down for you. I'm going to challenge you to see if you can prove these. Taking the reciprocal of a function does not change its evenness or oddness, as it turns out. See if you can prove that. Okay, so secant theta, being the reciprocal of cosine, is going to be an even function. And then cosecant theta, reciprocal of sine, and cotangent of theta, the reciprocal of tangent, those are going to be odd functions. Okay. All right. Well, this one's not too long here. Hope that this was helpful. Thanks for sticking around and visiting on my channel, Derivability. Why don't you give me a like or a subscribe? Share this with some classmates. Maybe you have some teachers or professors who would like to see this channel. All that would be great. Thanks again for stopping by, and we'll see you again soon.